Hey everybody, welcome to Geometry Section 5-4, Midsegments. By the end of this lesson, you should be able to understand the properties of midsegments, and you should also be able to use those properties of midsegments in order to find the missing values in a diagram. So let's go ahead and take a look at what a midsegment is. So here I've created a triangle, and on each triangle I've created the midpoint, or on each side of the triangle I've created the midpoint, and then I've connected those three midpoints. So it's kind of like we've got a triangle inside the triangle. And ultimately it looks like there's four triangles inside that triangle. So you see that this is different than any of the other segments that we've talked about. You know how all the angle bisectors met at one point of concurrency, all the perpendicular bisectors met at one point of concurrency, etc., etc. The midsegment is different because they do not meet all at the same point. You can see the three midsegments make a triangle, but they don't all meet at one point. So that kind of limits all the cool stuff that it can do. But notice what I've done is I've created the three midsegments, a green one, a blue one, and a red one. And watch how each side interacts with its other side of the same color. So I'm looking at the two blue sides, the blue midsegment and the blue side of the whole triangle. What do you think is true about the two blue pieces? Watch how I move it. What happens to those two blue lines? Okay, if you said that those two blue lines or those two red lines or those two green lines, they appear to be parallel, you are correct. A midsegment and its opposite side will always be parallel. Okay, what would you guess is true about the blue midsegment compared to the blue side of the triangle? Obviously, they're two different lengths, but how does the blue side of the midsegment correspond to that other blue side? If you take a look at what I'm doing, if I move this triangle, that blue midsegment can come down right there, or it can come down on the other side exactly the same way. So if you said that the midsegment, the blue midsegment, is half as much as the blue side, you are correct there too. So those are the two qualities of the midsegment, is they are parallel to the opposite side and they are exactly half as long as the opposite side. So let's take a look at the notes. The midsegment of a triangle is a segment that connects the midpoints of two sides of a triangle. So the midsegment theorem has two parts to it, and we've already discussed that. If a segment is a midsegment of a triangle, then it is parallel to the third side. It is also 1/2 the length to the third side. So those are the two main properties you need to know. Now I'm going to go through this little proof here, and I'm going to do it as quickly as I can because you're not going to have to do this. You're not going to have to know this, but it's just proving to you those two properties. So here we have 3 points in a triangle, Q, O, and P. It says that M is the midpoint of OP. So if I take a look at OP and I want to find the midpoint, I've done the calculations already, so you don't have to worry about this, but the midpoint there is 5, 4. And N is the midpoint of PQ, and that is 7, 2. All right, so it says find the slope. Okay, let's go ahead and draw that midsegment. And it says find the slope of MN and PQ. So the slope of MN, well, if I just count rise and run, it looks like I'm going -1. And the slope of OQ looks like if I count the rise and the run, I'm also getting -1. So the two slopes are the exact same, so that's proof that the midsegment and the third side are parallel. Find the length of MN. So the length of MN, if I do a right triangle here. And I do some Pythagorean theorem. 2 squared plus 2 squared equals c squared. So 4 plus 4. And then I take the square root of both sides. Let me punch that in my handy dandy calculator. So square root of 8 is 2.8. And so if I find the length of OQ, I can make another little right triangle there. That side is 4, that side is 4. If I go ahead and do that, that's going to be the square root of 32, which is 5.6. And in case you didn't know, 2.8 is exactly half the length of 5.6. So there we have proof of the two things in the midsegment theorem, that MN and OP are parallel, and that MN is exactly half the length of OQ. All right, so now that we've proven it, let's move on to the stuff that you're really going to have to do. Let's take a look at these diagrams here. So let's figure out X in this first one. So here's what a lot of people will do. They'll look at that and say, oh, 6X equals 36. But that's missing the whole point of the midsegment theorem. The idea is that this midsegment is half as much as the actual side. So one way you can do it is you can say, well, if that side is 36, then that midsegment has to be 18. And you can write the equation 6x equals 18 and solve that. Okay, that's one way of doing it. If we take a look over here at this other example, and again, you can tell it's the midsegment because I've got these hatch marks, so I know that's the midpoint. Over here, I've got these single hatch marks, that's the midpoint. So I'm connecting these two midpoints, so I know that 2x plus 3 is the midsegment. So if I tried to use that same strategy from the first problem, if I try to take 5x plus 4 and cut it in half, it gets a little ugly. So another thing that you can do is you can double the midsegment. And I can say 4x plus 6 equals 5x plus 4. That way you can avoid decimals and fractions and stuff like that. That's the way I do it. So just take the midsegment, double it, and set it equal to the opposite side. Do a little bit of algebra magic, subtract the 4x, subtract the 4, and I get x equals 2. All right, let's get this middle problem here. So given that AD is 3, so if AD is 3 and D is the midpoint, then I know that DB is also 3. Given that DF is 5, so if DF is 5, then I know that AC is 10, and BC is 8. So if this whole thing is 8, then I know that DE has to be 4. So let's see how many problems we've actually solved already. So BD, yep, we knew that. That's 3. DE is 4. AC is 10. And EF. Okay, so EF, we need to do a little bit of work on. Well, that's a midsegment. I know it's going to be half as much as the opposite side. So since AB is a combined length of 6, I know that EF has to be 3. And some people might look at that and say, well, if you got 3 here and 3 here, isn't that the same as the 3 here? Yeah, that would work. That would absolutely work. Okay? Let's take a look at our next problem. Oh, man, now we're throwing angles into the mix. Oh, this is crazy. So it wants us to figure out Vx. So Vx is that midsegment. So since GH is 46, I know that Vx has to be half of that. So Vx is 23. HJ. So HJ is the length of the side of the triangle. So I know that if WV is the midsegment, which is 27, then HJ has to be double that. So HJ is 54. The measure of angle of VXJ. So VXJ. So this angle right here. Okay, we haven't dealt with angles yet, but yet we have. Because one of the things about the midsegment theorem is that it creates parallel lines. So I know that VX is parallel to HG. And then I know this 92. Well, it looks like this 92 and the angle we're looking for are corresponding angles. So be on the lookout for corresponding angles, also alternate interior angles in midsegments. So I know angle VXJ is also 92 degrees. And finally, XJ. See, XJ, that's part of the side of the triangle. It's not the full side of the triangle, all right? But if VW is 27, then XJ is also 27. Now, I may have drawn on that too much to be clear, but we'll do examples in class, and hopefully this won't be too bad for you. All right, last question here. Let's get a different color. So it wants to know ST, which is this whole length there. So if DC is 36, then I double that, and ST is going to be 72. DE. DE is that midsegment. So since RT is 44, I know DE is going to be 22. Angle DES. So that's this angle right here. Okay, so the only other angle I have is 58, which, because ST is parallel to DC, let me clear that up a little bit. It looks like the 58 degree and angle SED are alternate interior angles. So they're going to be the same, so 58 degrees. And lastly, angle RCD. So RCD is right there. And there's the angle of 58. Again, looks like we've got some alternate interior angles. So angle RCD is going to be 58 degrees as well. Now, it's not always a guarantee that the one angle measurement in there they give you is going to be the answer for all your angle measurements. It just happens to be in the two problems that we saw. So hopefully midsegment wasn't too bad. That should be the easiest segment of all the things that we've covered so far. So if you guys have any questions, please feel free to ask me in class or email me. And hopefully you guys will find this fairly easy. I look forward to seeing you guys soon. So have a good one.